Hello, welcome to the Blazor Community Standup. I'm John Galloway. They let me back in the studio for this one since Dan Roth's out, and welcoming back Javier.
Hello,
Welcome.
everyone.
All right, so today maybe a quick one. We've got a busy release day as .NET 10 Preview 5 is going out. Dan asked me to remind you that one of the big things in .NET 10 Preview 5 is the stuff that was shown off, I guess, last week, which was the connection metrics and stuff like that, right?
Yep.
Exciting stuff. So I think, Javier, today we're going to be jumping right into showing your demo and stuff, and you're going to be talking about the state persistence, correct?
Yeah. So this is one of the kind of like most highly requested features in our backlog, and essentially this feature is about being able to have more resilient Blazor server applications. There are many situations when you have a Blazor server app and you lose the connection, for example, because the user switches to a different tab and the browser decides to hibernate the tab or to put the tab to sleep, that it will close the signal connections and it will essentially disconnect the circuit or the session. And by default, we only maintain the state on the server for around 3 minutes, although you can configure this to different limits. And the problem that happens is when the user comes back, maybe after an hour or something like that, the tab tries to reconnect and it finds that the state is gone and whatever the user was doing at the time is lost. So this feature essentially allows developers to decide which state on their existing app they want to save. And the idea here is that when the session gets disconnected, when we are about to discard the session, we trigger a process to save the state, which is similar to the process that happens during pre-rendering. And we store that state for a longer period of time. In the demo that I'm going to show you, is not present, but you'll even be able to store this state externally, like in Redis and so on. So the idea here is that by allowing you to persist that state, we save the current components that are on the page plus that state. And whenever the user comes back, if we see that the state on the server is gone, we recreate the app from the components that we persisted and the state that we saved at the time.
Okay.
So that
this is stateside persistence, and this is where you mentioned Redis, right? So this is applicable only to which makes sense. It's Blazor server.
So that gives you an opportunity to save that, to essentially get your user back to where it was, when in the past you would have had to reload the page essentially.
Yeah, which could be expensive if you're expensive in terms of database queries or whatever. But in some cases, there's no way to know what the state was if they've navigated through, made some selections on some things and filters and whatever. So
exactly, but that is all things that you can capture while you are developing your app, and you can choose to persist those things so that whenever this situation happens, you can get right back to the exact same UI that you were seeing before.
Awesome. Okay. Should we go to your demo then?
Awesome. So can you see my screen?
Got it.
Okay, so the demo that I'm going to show you is very simple, and it builds on some of the concepts that I know we've shown in the past. So we mentioned that whenever we wanted to persist a state during pre-rendering in Preview 3, I believe, we added this beautiful name, supply parameter from persistent component state. That was a declarative model for saving the state that we generated during pre-rendering and being able to reuse that state when the application became interactive.
I have to ask, since someone always does, so that currently supply parameter from persistent component state, I think at the time you said that this was a name that you picked as a place filler that we were definitely going to change.
Yes, and we're definitely going to change it, I promise. It's still going to be the case. We've just been busy kind of like working on the core of other features, and we need to go through the API review process for this, but it's planned.
Okay.
Lots of people have taken vacation at disjoint times and has made having these discussions a bit harder.
Okay.
But yes, nobody likes this name, not even I, and it's obviously going to be something much simpler.
Okay.
Okay, so the only thing that I've done to this app is I've set the like max number of like circuit retained to 0. So this is essentially a way of telling Blazor, do not hold the circuit in memory, just like discard it right away.
Okay.
And what this is going to do is going to allow us to trigger the persistence. So I am going to run the app now.
So if you hadn't set that disconnected circuit max maintain thing, then it would keep it around until whenever the cleanup happens.
Exactly, which is normally by default for 3 minutes.
Okay.
So this is a way of like forcing what we want to see. So I have my Blazor app here that has already initialized. I'm going to go back to my counter component. In my counter component, I am going to put a breakpoint here. I'm going to explain to you why I'm putting a breakpoint here. Whenever we reconnect to a circuit, the circuit in memory is the same instance, okay? So if we are reconnecting, we will not see this endpoint being hit twice. In fact, let me just refresh the page. We're going to see it hit 2 times right now. Or maybe not. I'm not sure why it didn't refresh. Oh, it's because, sorry, we're not going to hit the breakpoint if I don't attach to it. For some reason, I launch without attaching. Let me just go ahead and attach. Okay, so now we are hitting it the first time during pre-rendering. Okay, and now we're hitting it the second time after pre-rendering. So I am going to click a couple times, and I'm going to open the DevTools because in order to like simulate a reconnection, I need to do some hacky things. Let's just put it like that. So I'm not showing you, but I'm manipulating the console to trigger the reconnection. So now you see here the like reconnection UI, and I am going to like trigger the like a continuation for the reconnection callback. And what's happening is that we're gonna hit that that current counter breakpoint another time. So that's our key to know that we have the existing circuit with its state. So you can see here that the current counter is 2 and that the circuit is already initialized and it came from the persistent state. So I'm gonna continue running the app, and if you can see, I can still click, I can do things, so I can interact with the app as if nothing happened. But in this case, we didn't have to maintain the entire circuit in memory, and we were just able to bring it back from the state that we saved and the components that we have rendered on the page. And you might be asking yourself, what's the difference between having the circuit disconnected versus persisting the state? And there are a couple of important differences. The first meaningful difference is that when a circuit is disconnected, it's still in memory. If you have something running on a timer or anything like that, the circuit might still be doing work, consuming CPU resources and other things, and just accumulating stuff, waiting for you to reconnect, at which point it will send all that stuff, all those updates back to the client. So that's extra memory and extra CPU that you are consuming when something is not being used, which is the disconnected circuit. The other part is that the amount of memory that like a circuit consumes is bigger because it has to maintain all the componentry and all those things in memory. And it's also much harder to measure because you need to measure like an object graph and so on, which is not easy to measure, and it's not super easy to make calculations for scaling and sizing things. In comparison, when we persist the state, we know exactly the size of those things. The reason for it is because everything gets serialized, and you can see that it's 10 kilobytes, 15 kilobytes, 20 kilobytes. You have actually a hard limit, which is around 32 kilobytes, which is the default in our message size. You can also see this very easily when you render the page, because since we are reusing the same mechanism as pre-rendering, if you look at your initial like page load and you look at the size for it, you'll see that that is the size of the markup plus the pre-render components plus whatever state you had at the time of pre-rendering. So it's much easier to like have a lot of persistent circuit state lying around. The other part, which is the ultimate interesting point, is that we are currently saving this state on the server, but you can obviously push this state to Redis and to any other like third-party service that you want. And our plan is to include support for hybrid cache within our implementation, so that if we detect that you have registered hybrid cache, we will automatically start using that for persisting the circuit state. So if you have configured a Redis backend or an Azure storage backend with that hybrid cache implementation, then we will persist the state to that. We will not even keep it around on the server. By default, if you don't have anything configured, we will keep the server state in memory on the server. But
can you talk a little bit about how to do that? Like you said, you could persist the state to Redis or something. Where would you set that up?
Yeah, so I don't have it right now in this branch of the code, but essentially it will happen automatically if you in your program.cs call services.add hybrid cache. Then that will automatically, we will detect that and we'll start automatically using the hybrid cache version.
Okay.
And in fact, there will be a hybrid cache property here in options. And essentially you get to set that to your own hybrid cache. If you want to have a separate hybrid cache completely with different limits, completely independent from anything else, you get to also configure a unique instance for Blazor.
And it's been a little bit since we had a hybrid cache show, but that's really, hybrid cache is great because it does allow like, I'll probably mess this up and you correct me, but the hybrid cache can work with like a memory and a backing store and can like automatically switch between those and stuff, right?
Yeah. So I'm going to try and not butcher it, but essentially hybrid cache offers you a unified API for dealing with caches, whether it's local or whether it's distributed. It offers additional stuff like Stampede support and other caching things that I don't remember off the top of my head. But the good thing about it is that you can depend on hybrid cache, and then if you plug in a distributed Redis cache or you plug in a distributed blob storage cache implementation, it will automatically start using those.
Okay. Is there, how does this work? So actually this kind of relates to a question that just came in from RPS here, are improvements to persistence for interactive auto. And I was thinking just generally along the lines here, like interactive auto, you've got the initial state is, you've got pre-render, you've got the server side, well, the WebAssembly is being transferred, and then you switch to WebAssembly. How would this work in the case of like an interactive auto page?
So for interactive auto, you are essentially dealing with pre-rendering and with enhanced navigation. So the first time that you render the page, it will pre-render, it will start with Blazor server. You have some state there. The next time that you navigate, the app will pre-render again, and if that component switches, the state will right now be lost. This is something that that we might tackle in the future, but the main goal for right now was to improve the resilience in the Blazor server case. There is another issue that we are trying to get done for Preview 10. Sorry, for Preview 10, for dotnet 10, which is supporting persistent component state across enhanced navigation, which we currently don't. That might also help in that case.
Okay. Question here from Necrocultist. What is the impact of persistent state on memory with 10K plus clients? So obviously, like you mentioned, things like persisting, like where that persistence is, and if it's in Redis or something like that. How would you think about this for a large scale app?
So the way I think about it is as follows. Let me just like bring back here the dev tools. I'm just gonna like clean this stuff, and I'm just gonna refresh the page right now. Let me just remove that breakpoint from there. Okay, so the way I think about it is that this page is around 9.2K. And this is pre-rendering. So let's actually do something like, actually, no, never mind. So the way I would think about this is I would measure the size during pre-rendering with the understanding that the state during pre-rendering is somewhat similar to any state that you are gonna have later on, even if you add a bunch of extra content, because in the end, the size of your screen is limited, and you always get to choose what you need to save and what you don't. You might want to persist some data that you retrieve from the database that like has a super expensive query and that you don't want to be running unless like really, really necessary. Or you might choose that it's okay to just like get a refresh version of that data.
So you could have a persistent state variable that's actually not displayed on the screen, right? It's just a parameter marked with persistent state.
And in fact, this is what our tests do, like because we need to validate those things. So we need to validate that we are restoring instead of reconnecting. We have like here we just do like GUID .new GUID, and this state is not saved. When you like restore, this is gonna generate a new unique number.
Yeah.
Every time, and that's fine. In this case, it's something as like quote simple as a GUID, but you could be thinking of like any other status that you might be showing. You might just like recompute that. So with this model, it's completely opt-in. You get to choose what you want to save, but by having a standard language that everybody uses and a standard mechanism that everybody gets to plug in, you can imagine that you can be a library author and create components that are already persistent ready. You can think of someone creating a new implementation for hybrid cache. You automatically get to benefit from that new backend, and so on.
So I would think maybe like for a more complicated case, let's say I've got a quick grid and a bunch of filters. I just whack that supply parameter from persistent component state, whatever parameter on anything else, any of my parameters, and that's easy to just kind of, it's just automatic then.
Yeah, exactly. So I would create a class to hold all the state that I want to save, and I will use that through my code base, and I will put it exactly like this, and that gives you a guarantee that whenever like you are reconnecting, we are going to, when we are restoring the circuit, we are going to save that and bring back any state that you persisted.
So in the case that, let's say I left that off of one of the parameters, and so does the page, I'm trying to think how this works. Like the page reconnects, the circuit says, or the page like wakes up essentially and says, okay, I've got these parameters, but I'm missing this one, so I can't render this page. Then what would happen there?
So that's a bug in your app, essentially,
Okay.
because you have a mix of, you have a combination that you have not thought and that you're not supporting. If you have a parameter that where the state is not there, normally what you do is same as we do here. You provide a default.
That's right. Okay.
So
it would load that default.
Yeah, the pattern that we follow with this, with supply parameter from query and things like that, is write on initialize and set the parameter with the null coalescing operator and the fallback to do whatever. So I don't know if fetch data does the same thing right now. No, but yeah, whenever you're doing fetching any data or anything like that that is persisted, just null coalescing operator, and that's the pattern to follow.
Okay.
There's
I
another
like
thing.
how it's recommending status change. That's what I do every time I need to refresh the UI and I don't know what's wrong. I just drop a few status change.
Yes, if you sprinkle everywhere, it will work.
Yeah. I had a few questions come in. Let me see. So
yes.
This is will this make it so pre-rendered data won't be loaded again on pre-rendering, and like solving the case of API requests twice during pre-render. And then Team Droid's also asking, I'm just kind of lumping these all together, but even CSS with animations and pre-rendering twice. I honestly, as a kind of novice or still learning Blazor developer, run into this where I'm not 100% sure on the pre-render and then the render again.
So I can talk a bit about that, and after that, I'm gonna show you another demo, which I think is important. So I want to make sure that we don't miss it. In general, Blazor renders twice. It first renders during pre-rendering, where it generates all the markup and discards all the state. And after everything has been rendered on the page, then JavaScript kicks off, finds all the components that you rendered that you wanted to have interactivity, and re-renders those components using the circuit. And that's what normally people see when we render twice. The supply parameter from persistent component state part of the equation helps with what is called hydration, helps with making sure that you don't have to fetch the state or the data twice, that you get to fetch the state during pre-rendering, you get to send that to the client, and when we start interactive, you are able to produce the same exact picture that you produce when you were done pre-rendering without having to go and fetch all the data.
Okay.
So the part that this doesn't address is the fact that whenever we are rendering interactively, we remove all the pre-render content and we put all the interactive content in. So that normally causes animations to rerun, videos to replay and stuff like that, because we are adding new nodes to the DOM as opposed to detecting the ones that are already there. The reason we don't do that is because it's hard. In the easy case, you might think that well, if you're producing the same thing, it should be relatively simple to go through and make sure that you don't add stuff that you don't need. But we also need to deal with the case where you're rendering again and you're rendering something completely different. One example of this is if you are rendering something asynchronously with a fetch data or something like that goes and makes an API call, and you have a loading state in your app. We need to detect cases oh, the markup is completely different. We need to strip everything out and and put new content in. And we need to get that 100% right, because if we don't get that 100% right, then your app is going to fail at some point in a location where like you're not clear about why it's failing. So we do have that in our backlog, and that's something that maybe we explore post 10, but it's not an easy thing to do. And that's the reason why we haven't done it so far.
So as a developer, is there something that I can do to say like, hey, I don't want this animation to play twice? Do I set some kind of local parameter and check it in JavaScript, or do something there? Or?
So with animations, it's hard. I am not an expert, by the way, on animations. I believe it's hard because essentially, if you, for example, have an animation that gets triggered when like something enters the DOM, you typically have declared that with like some JavaScript, with some CSS and a starting style rule or something like that, that then automatically triggers a transition. The things that I can think of is if you are able to register an event handler, I believe there are ways of getting the current animations, and maybe you get to stop them. There are other situations where you could, for example, render or add an attribute to the page only in interactive mode or only in non-interactive mode, and use that to key off the animation so that you make sure that it doesn't run once.
Yeah.
Because we're going to replace the DOM in one pass. Okay, so you're not gonna see like an intermediate state. If I like to make this explanation of Blazor, that Blazor is like a video camera that takes, or like a camera that like takes snapshots of the DOM every time, every certain amount of time, and sends them to the browser. All those snapshots happen atomically. So the idea behind the way we do pre-rendering at the state is that if you are able to capture the picture at the end of pre-rendering and persist that state, whenever you render interactively, you should be able to also get that state in one batch or in one screenshot. So if the previous image and the next one is the same, then you visually don't see any change. The challenge obviously happens when you have animations and things like that, because of the way we handle the DOM in the interactive scenarios when we are coming back from pre-rendering. But that's something that we might try and address in the future.
Okay. We've got a few questions. I've got 3 more questions here. Can I take those now, or do you want to get to your demo first?
Let me do another part of the demo.
Okay.
Because one of the things that I show you so far is what happens during this connection, but I think people is going to be more excited about what I'm going to show now.
Okay.
Visual Studio decided to like start building very slowly. Okay. Okay, so I'm gonna go back to my counter here. And one of the things that we saw is that like, hey, if the app gets disconnected, then we can save the state and persist it. But wouldn't it be cool if you were able to do things like, well, I'm gonna detect that this app is not doing anything. I'm gonna save some resources by just like persisting it. So there is a new JavaScript API that we're adding, which is Blazor Pause. And what this is going to do is precisely that. It's going to persist the app state proactively for you. And it has another interesting quality, which is we are going to save that state in the browser instead of in your like server. So you don't pay for cache, you pay the user machine or the client is the one that gets to pay for storing that state. And then obviously there is an experience around it when in this case I'm showing a UI, but this is completely customizable. you could choose to not show anything and just pretend that nothing happened. And the moment you detect the mouse move or something like that, you could like restart resuming the app. In this case, by default, so far, the experience is that we use the same dialogue.
Yep.
Yeah. But in this case, we say, hey, the app has been resumed. And then if we click resume, then we are back to like the app and we can continue interacting with it. But all the time, the app was not wasting memory on the server, wasn't using CPU on the server or anything like that. So this offers you a lot of possibilities in terms of like, you might know that like after 5 p.m., no app should be like working. You might choose to like persist the app after like 5 p.m. And save on resources, or you might, for example, decide to persist the app when someone minimizes the tab through like a visibility change event and so on, and then restore it. So that allows you to keep to make all these sessions much lighter weight because you are not paying for anything on the server. Now, I would caution that while this works, you also need to be careful because you are introducing new transitions in your app where like you might be creating errors for the end user that you didn't realize. In this case, for example, I'm just like doing the count here and I pause the app, but you need to ask yourself, okay, what if I try to resume the app now and it fails because I had a bug or something like that in my app that like made it so that the state got lost? I have now caused the user to lose their state unnecessarily because this wouldn't have happened if I did not manually pause the app. So you can think of like doing this every 10 seconds, maybe, but keep in mind that you'll have to test this through to make sure that you are not that you don't run into situations where you have a bug and you cause the user to lose their state. Because in the disconnection case, is a progressive enhancement. The state was already lost when we decided to like discard the circuit. We're giving you an extra chance to save it and restore it from there. But in the case where you're triggering this proactively, you need to be sure that that you test that you're able to resume the app from the state. And obviously there are APIs here in Blazor, so you can write end-to-end tests using Playwright or something like that to just validate this. But I felt it's important enough to bring this up because I've already heard people on the team and in other forums saying, oh, I can do now this every 2 seconds.
Right.
And simply recreate a more expensive version of view state. And that's not optimal.
Yeah.
The whole point of this is make sure that if something is being used, keep it on the server. It doesn't have to like go back and forth every time. And whenever you feel that someone is not using the app, you get a chance to store it and save on resources at the cost of having to make sure that you're able to get back to where you were with the state that you saved. It shouldn't be super hard because the same mechanism that we use for this is the same mechanism that is used for pre-rendering. So if you are testing pre-rendering, you are, for a large part, testing this behavior.
Okay. But every time you do that transition, resuming, there's both potential for a bug, and then there's also some reconnection thing that you've got to do. So like you're saying, if you're doing that every 2 seconds, you're probably causing more work than you're saving as far as server and everything too, right? Exactly,
because we need to recreate the circuit, we need to recreate all the components still need to render on the server, and like it's not free either.
Okay. All right. But like you're saying, times where it's like, hey, it's after work hours, or after an hour of inactivity or after minimizing the tab or something like that, then you could you could do that then. Awesome.
Yeah,
Okay.
and we give you the API, so you have full control over what you can do there.
Okay. And you showed calling that via JavaScript, but there's also like, I'm assuming there's I could call that in my code in my Razor page, or my Blazor page as well, right?
So there is an API that we are exploring for doing it from the server, but it's a bit more tricky.
Mm.
In the end, if you want to call it from the server, you can just like, it's not going to be exactly like this. Inject.
Oh, right.
So you could just literally just get the JS runtime and here do.
Okay.
It would not be exactly like this, but yes, you could do something like this.
Okay.
That said, I would recommend avoiding doing this from within Blazor because kind of stopping yourself is somewhat like problematic, I think. So it might be better. You might be better off just having a button with an event handler, like the same thing that I did here. You could like have a button here that does it.
Okay. All right. Got a few questions that came in if we're ready for those.
Yeah.
Okay, let's go.
Let me switch back to here so that I can see you.
Okay. So is it using an ID for the anti-forgery cookie to reconnect on the same circuit?
So first of all, it does not reconnect to the same circuit. When we are resuming, it creates a new circuit from scratch. And the beauty of it is that resuming an app is no different from starting a new circuit from scratch. Because all that we do is when we start a circuit is tell the browser, here are the root components that the user pre-rendered or defined during the initial server rendering, plus here's the state that they saved. What this feature does is it captures the set of like root components that were on the circuit, plus the state at the time where we decided to pause the circuit. And if that is in JavaScript, then JavaScript sends all that information back to the server and says, hey, please resume the circuit. Here are the root components at the time the circuit was paused, and here's the state at the time the circuit was paused, and it's exactly the same as starting a new circuit.
Okay, so kind of related here, John Muller is asking, with regard to the session using authentication authorization session timeout, are you forced to re-sign, or will the state be automatically restored afterwards? So I think what you're saying is you're just resuming the state that's been stored, but like for the authentication case, how do we handle that case of like connecting to an authenticated session?
Every time a circuit reconnects, we revalidate the authentication. So if whenever you are resuming, before resuming the circuit, we actually have to connect the circuit. So we establish the signal connection, and during that establishment of the signal connection, the user identity gets reevaluated. So if it happened at the time that like the user, for example, got logged off because the cookie expired or something like that, even if you have the state, the authorization pieces in place are going to make it so that you are no longer able to access that UI. And what's going to happen is that we're going to render the not authorized fragment or something like that.
Okay. As you're saying there, that authentication state's just stored in the cookie. That's handled normal browser mechanisms and stuff there.
Yeah, interactive server by default considers that the lifetime of the like SignalR connection,
Mhm.
the authentication doesn't change. It's kind of like it's the same thing as when you send a request to the server, and that request spans for like 30 minutes. There's no way for you during those 30 minutes to reevaluate that identity because it came on a cookie that was valid at the time. You need to have some external mechanism, which is what the revalidating authentication provider in Blazor does, to check the database. For example, if you have an identity user, check that the timestamp has not changed or anything like that, to periodically check. And it's an artifact of using cookies. Cookies require HTTP request. Whenever you like establish a WebSocket, you're still on the original HTTP request that got upgraded.
Okay. All right. Great questions. Keep them coming in. Let me see here. If I have an in-memory object for persisting state injected as a scoped resource that I want to notify components when it's changed, what's the best way to implement this behavior?
Okay. So let me process the question for a second. So first of all, we showed storing state on how do I say it? We showed storing state on the components, but it's equally valid to store the state on services. I remember us showing that during the like previous demos where we did pre-rendering. There is a persistent service or something like that. I don't remember how it's called, that you can use to register some service, and we will persist the state of the service and restore it during pre-rendering, and the same thing happens here.
So I've run into this too, where the whole kind of like notifying components on change, that's where I got into the sprinkling the status changed all over the place because I wasn't honestly sure. Is that something where like the whole kind of notifying components, because sometimes it's a resource that is not automatically going to be picked up by the component that the underlying thing has changed? Or
so there are a couple of ways of doing it. One is you could create a cascading value and then wrap your component in that cascading value and use the service to essentially subscribe to an event that tells you when the thing has changed, and then the cascading value produces an update. And that way your component doesn't need to like do that. Or you can inject that would be the cleaner one. The other thing that you can do is you inject the service, you subscribe to the event, and in your event, you save the new value and your trigger state has changed.
Okay. All right. Last question we've got open here. Why does Blazor JS not get the state from the circuit in auto interactive instead of pre-rendering?
I'm not fully sure what that means.
So I guess if you're in auto interactive, can Blazor JS get the state instead of? So you were talking before about like we need to go through this re-render because we're not sure. We want to make sure that whatever the state is, like everything is getting rendered. Is it possible for Blazor JS to handle that, like to figure out what the state is?
I'm still not surely sure that I understand the question, but if we are talking about transferring the state from interactive server to interactive WebAssembly, in the case of auto components, is another big complicated piece of work that we might tackle in the future, or we might explore in the future, but that we're not doing right now because it's complicated essentially. So
I think as you pointed out too, that like a lot of the things where I'm like, why isn't it just doing this? You mentioned there that there's a lot of things where if you get it wrong, there's a lot that causes a lot of issues, right? And it's like something where it's like if you guess incorrectly and don't render some important data, or don't catch something that was in an async state or whatever, then the page it's a difficult bug to figure out then from a developer point of view.
Yeah, and even auto has its problems. Like what happens when you have an auto component and it works fine on the server, but then on the next page you like render it on JavaScript and it has an error. You are essentially making something that worked. You're causing it to stop working because it doesn't work because you have a bug in WebAssembly. So the way currently auto works, it involves making or doing a page refresh. It might be that in the future we are able to do that without the page refresh, where we are able to like spin up things in the background and we get to do a similar dance like what we are currently doing to pass the state between the server and the client. So you could imagine us stopping all the components on the server and then like restarting them on the client. But just how complex it is describing you should like give you a good idea that it's not a trivial thing to do. You have to worry about things like security and information leaking, things like that. You want to make sure that some state that is important on the server doesn't reach the browser, for example. Because whenever we do all these dance where we persist the state, we push it to the client and so on, all the state is protected using data protection. So we are able to guarantee that you cannot tamper with it, that you cannot pick, and that no one can like pick through it.
Okay. That's all the questions we've got. We do have a few just fans with some shout outs here. I love Blazor. And then I love this one. I've been using Blazor for the past 6 years, made 10 plus medium to large projects. And for me, Blazor was a godsend. Thanks, team. So that's always good to hear.
Awesome.
Wow. All right. Well, that's all the questions we've got. So I think you covered everything you were planning to show.
Yep.
Awesome.
So.
Okay. Well, stay tuned. We've got Preview 5 coming out today. And then I guess just as a reminder, if people have, questions or want to interact, they can file issues and follow along on the repo then, right?
Yep.
Awesome. Okay.
Awesome. Well, thank you, everyone.
Yep. I'll wrap up here. Let me go find the thanks for watching video, and thanks, folks.